Hi, my name is Johnsen. I'm going to present today on the simulated environment that I created, which combines several software packages out there and some modern AI techniques and computer vision methods, along with some good reinforcement learning stuff. Pretty much the idea is for autonomous drones. It can be applied to other vehicles such as rovers and cars, but my focus was on drones because they're pretty sweet. So my current mentor is Dr. Marco Loverado over at UCI. I am, however, looking for an SDSU advisor. So if you're interested, there's my email, tjohnsen, tjohnsen, at sdsu.edu. Please hit me up. So here is an example of what it looks like from the environment. Unreal Engine is used to render graphics. They have a large asset store, which is really important because we can download, various things like bushes, cars, houses, mountains, whatever environment you're in. Unreal Engine is originally made for video games. However, it's branching off into simulated scientific environments pretty quickly now. I think it's getting some more momentum. So the main idea with this drone here, you see it in the middle, and this drone is being dropped in by an external package called Microsoft AirSim. Their entire goal is to add these drone physics with this drone along with some sensor readings. Right now I'm just showing you some RGB images and some depth estimations. You see the depth on the far left, it's grayscaled. In the middle, there's some segmentation, some scene segmentation showing you like where the road is and stuff like that. And on the right is the raw image view. So I created some Python code that can kind of make these all communicate together and add some more things to it. So on this one right here, we see class vision on the far right. So the goal of this is to create whatever image we have, transform it into whatever transformation we need. And I know that sounds vague. I said it vague on purpose though, because there's a lot of transformations you can do with these images, such as surface normals, object detection, object tracking, object segmentation. Those are all different things. You can also do depth estimation. So I left this modulated so the user can rotate in and out different things so they can track whatever it is they're trying to do. Now the decision module is in the middle. That one's a little bit more complicated. That uses some reinforcement learning, which I'll get to more towards the end. But the idea is to take in all this information from the different sensors after they have been, transformed a little bit and manipulated in the right way so that the decision module can read it correctly. Then it decides what the drone does next, considering things such as mission parameters and not colliding into anything. The drone module is also modulated so that it can work with the Unreal Engine, any other sim environments, any drone you want. You can go and just issue the same commands. However, how it handles the commands depends on the module. Now, I packaged this all up in a nice little Singularity container. I'm looking at a Docker one too. I guess it's just there for personal preference, what people are more used to using. The whole idea is to make it plug and play though. So you don't have to worry about setting up all these environments, making them work together. I already have that set for you. So here's an example of the vision module. I did this outside my apartment with my DJI Tello drone. And you can see the left is the raw output, the middle is RGB depth estimation, the far right is grayscale. It's pretty blurry, so it's not perfect. It's saying one of the many things bottlenecking drone autonomy. I could talk about all the things bottlenecking it for a while, but we'll move on. Object detection is another vision module. This is done with a convolutional neural network typically. It's also done with a UNet. You can see on the right, it pulls out different objects such as the cat, the person, the car in the background, the street lights. All those things are important to detect so that the drone doesn't collide with it or if it's looking for something specific. Now a basic decision-making module would just use the depth estimation from the RGB image and throw a score to each direction, say like up, down, left, right, diagonal, and score based on how close things are, and then pretty much pick a direction that doesn't have something close to it and go in that direction. However, something I'm working on now is something that is much more complicated, and that is using deep multimodal reinforcement learning. And that's taking things such as LiDAR, which bounce lasers off of the drone to see how far everything is, and combining it with the RGB, and then using Q learning to decide what the next path forward is. Thank you.